Assalamualaikum and salam sejahtera. Today we will continue our learning for the chapter 2. The first subtopic is properties of pure substance. Here is the example for pure substance, which consists of solid, liquid, and gas. So, what is pure substance? Pure substance is a substance that has a fixed chemical composition throughout. It may exist in more than one phase. For the example, like water, mixture of liquid water, carbon dioxide, nitrogen, and mixture of gas. For figure 3.1 shows the nitrogen and air as a pure substance. And for the figure 3.2, for A shows a H2O, which consists of vapor and liquid as a pure substance. But for the air and liquid, for the second figure, it is not a pure substance because the air is in gaseous state. This figure shows electricity generation by nuclear power, which involve some device, which are heat exchanger, steam condenser, turbine, and generator. In this process, the steam will be generated by turbine and convert to electricity. So for the details about the importance of steam, you can refer to the link given in this slide. Here is the some application for steam. Steam is used in a wide range of industry like heating, propulsion, motive, atomization, cleaning, moisturization, and humidification. As an example, application of steam for heating as a positive pressure steam, and then vacuum steam, steam for propulsion drive to generate electricity, steam as motive fluid, steam for atomization, for cleaning, for moisturization, humidification. So if you want to read more, you can click the link in the slide, and if you have any question, you can ask your lecturer for details explanation. This is a phase of pure substance. As you already know and learned before this, there are three different phases, which are the A is solid molecule, the B is for liquid phase, and C for gas phase. This is a TV diagram to show the phase change for pure substance. There are 6 phase change, which are the first one is compressed liquid region. It is the outside of the curve, this one. The second one is the purple line. That is a saturated liquid. The third one is liquid vapor saturation region or mixture of liquid vapor in the middle of the curve. The fourth one is saturated vapor line, the red line. The fifth one is superheated vapor region, which is outside the curve. And the last one is critical point. Critical point is a point before the saturated liquid change to saturated vapor. The point before saturated liquid change to saturated vapor. So this blue line is a isobar line. Isobar means constant pressure. What is that mean by constant pressure? It means same pressure. Okay, this is the diagram PV. P is pressure. V same as TV, which is a volume. So the state is same location, but the difference is the line. For the TV diagram, we have isobar line. So for the PV diagram, we have isotherm line. Isotherm is constant temperature. That means the temperature is same. So the difference between PV and TV diagram. For the TV diagram, we have T for y-axis and for the x-axis remain constant, same as PV. And the other one different is the isobar line. So for TV we have isobar. But for PV we have isotherm. So the shape is different. This is a state for pure substance that I have explained earlier. So for the compressed liquid, it means a substance that is not about to vaporize. So for the example, you can refer to the state 1. Okay, state 1 is a water that exists in the liquid phase. So the liquid phase, we call it compressed liquid. Why we call it compressed liquid? Because the heat is supplied to the system. So the state is compressed liquid. And then for state 2, which is saturated liquid, a liquid that is about to vaporize. So when the heat is supplied to the system, so the water is ready to vaporize. So the state we call it saturated liquid. As example, for the water, the boiling point is 100 Celsius. So that one, in that state, 100 Celsius, the water is, we call it saturated liquid. Because after that, the saturated liquid change to liquid vapor mixture. Liquid vapor mixture means the liquid and the vapor phase coexist in equilibrium. So means the state mix of vapor and liquid. So as you can see here, as more heat is transferred, part of the saturated liquid vaporizes. So the water is in phase of liquid plus vapor. For the state 4, if we continue transfer the heat, supply means supply the heat. So all the water is transferred to saturated vapor. Okay, so what is saturated vapor? Saturated vapor that is about to condense. So, if we continue supply heat for saturated vapor, so the temperature will rise, then the phase change to superheated vapor. What is superheated vapor? A vapor that is not about to condense. As you can see for this figure, for example, at point A, this one, water with a specific volume, we call it VF, given by point B, exists together with steam with a specific volume given by point C. The dotted line on figure 10 are line of constant temperature. Okay, why constant temperature? Because the diagram is P versus V. So, the dotted line is isotherm. Isotherm, which means constant temperature. Okay, B, the phase for B is saturated liquid. The phase for C is saturated vapor. Otherwise, for A, it is a mixture of liquid and vapor. So, for the properties of wet mixture or mixture of liquid vapor, we have dryness fraction. Why we have dryness fraction? Because the phase is composition of liquid and steam. So, how to calculate the dryness fraction? Which symbol is X. The dryness fraction means mass of dry saturated steam divided by total mass. As example, for wet steam or mixture of liquid vapor, we have dryness fraction. Here at point A, the X is 0. Then for point B, the X is 1. So the value of X is larger than 0 but less than 1. That means the X value cannot exceed 1 and the X doesn't have in negative value because the X value must be larger than 0. Okay, for example, for this point, let's say the X is 0.2. That means the saturated steam is 0.2 and the saturated liquid is 0.8 because the dryness fraction means mass of saturated steam divided by total mass. So for this point, X is 0.8 means saturated steam is 0.8 and saturated liquid 0.2. So for the mixture of liquid vapor, we have some formula to calculate the properties. There are 4 properties we need to calculate. The first one is specific volume. Okay, what is mean by specific volume? It means the volume per some properties. As example, for this Vg is specific volume per unit kg. So we call it specific volume. But if volume, we have capital V and the unit is meter cube. Meter cube without per. So this one we call it volume. Specific volume have per kg. So for the specific volume, how to find specific volume? X times with Vg. What is Vg? Vg is specific volume of saturated steam. And then the second properties is enthalpy. Okay, this one is formula to find the enthalpy. Okay, this one is enthalpy and this one is specific enthalpy. Okay, as you can see the unit for enthalpy kilojoule. But for the specific enthalpy, we have per some properties. So for this one, the properties is kilojoule over kg, kilojoule per kg. So for the why we have this formula, because for the pressure above 70 bar in steam table, the specific internal energy not tabulated. So we can use this formula to find the internal energy. So back to the enthalpy. For the enthalpy, to calculate the specific enthalpy, the formula is H equal to HF plus X HFG. HF is specific enthalpy at saturated liquid, and Hg is specific enthalpy of saturated steam. And then the HFG is difference between Hg and HF, means Hg minus HF. The X is dryness fraction. The other properties is specific internal energy. So how to calculate the specific internal energy? So the formula is UF plus X UG minus UF. So UF is specific enthalpy of saturated liquid and UG is specific enthalpy of saturated steam. But in the steam table, we do not have UGF. So you must calculate UG minus UF because we don't have UFG. And then the last properties is specific entropy. So the formula for specific entropy is SF plus XSFG. SF specific enthalpy of saturated liquid and SG specific enthalpy of saturated steam. So the formula given SFG because in the steam table we have SFSG. So you do not have to manual calculation for SG minus SF. So remember, this is the equation that we have discussed earlier. The first one, V equal to XVG. Actually, for V equal to XVG, the origin formula is V equal to VF plus XVG. But the VF is too small, so we can assume VF as 0. So that's why the formula is V equal to XVG. So this one is formula for H, enthalpy, formula for internal energy, and formula for entropy. Don't worry, you do not have to memorize this formula because in assessment or examination, the formula already given for you. Here is explanation or definition about some properties that we have discussed earlier, which are specific volume, enthalpy, internal energy, and entropy. Hopefully, with this definition, you can understand the terms better. This is the steam table that we will use to find the properties to solve problem about pure substance. It is fifth edition. So here is the content to help you find the properties easier. And then for next page, it shows a notation and units. For properties, it can help you to find the properties easier. As example, other than that, it can help you to remember the symbol for the properties. As example, here we have the H. So if you forget what is the symbol for specific enthalpy, so you can refer here. The first one, H, is referred to specific enthalpy. So the second one, H wave, is referred to molar enthalpy. Okay. And then other than that, we have entropy, specific entropy as specific internal energy U, specific, where is the specific volume? Here is one, specific volume, we have V, and then we have delta T. T is temperature. Delta T is temperature difference. And then we have R for specific gas constant. And then we also have Cp, Cv for specific heat capacity at constant P, constant pressure for Cp, and specific heat capacity at constant V, volume. Okay. So notation and units can help you to remember the unit and the name of properties better. Here also have the subscripts. Example, F is referred to property of saturated liquid. As example, VF, SF, HF, and UF. G refers to property of saturated vapor, which are VG, SG, HG, and UG. For FG refers to change phase of constant pressure, which means Fg is the difference between Vg and Vf. So for this, we have VFG, SFG, HFG, and UFG. And the S is refers to saturation temperature or pressure. Okay, so for the next page, as you can see here, it's right, saturated water and steam. So this page you use if the phase for the question is saturated water and steam. But be careful because for the first page the value is starting with T, temperature. But if you see the second page for saturated water, the value is starting from P. So normally, we find the properties, use the P properties. Okay, as example, for saturated water, I give the question, find enthalpy at saturated liquid. Find enthalpy for the steam at saturated liquid, the water. Find enthalpy for the water at saturated. Okay, correction for the question. Let's say the example is find enthalpy for P equal to 20 bar for saturated liquid region. So the keyword is saturated liquid. As explained in page for notation and units, saturated liquid means F, refer to F. F means fluid. G.F, fluid. G is gas. So, the question asks about the enthalpy, specific enthalpy. So, H for saturated liquid. Saturated liquid is F. So, the question asks about the HF at 20 bar. So, you found P equal to 20 bar and read the HF. So, we go to P equal to 20 bar. Here is 20 bar. And then find the HF. Where is the HF? HF is the 1, 2, 3, 4, 5, 6 column. So 20, 6 column, 1, 2, 3, 4, 5, 6. Okay, here are the HF. So HF is 909 kilojoule over kg. Okay. Okay, another question. Find entropy at P equal to 10 bar for saturated vapor. So, if you forget what is that means for saturated vapor, so you can refer to notation and units. It states that saturated vapor is G. G refer to gas. So Vg, Sg, Sg and Ug. So for entropy, the symbol is S. So the question asks about the Sg. Then find the P equal to 10 bar. And after that, find the Sg. So Sg at the last column here. Okay, 6.586. So the S equal to 6.586 kilojoule over kg dot Kelvin. Okay. The steam table also have the unit. So after you write down your answer, you must include the unit. Okay, so the steam table have 1, 2, 3, 4. Okay, 4 page for saturated steam. This one is 4 page for 3, 2, 1. Okay, so don't forget for saturated steam, water and steam, it have 4 page, and after that it is about another phase which is superheated steam. So for superheated steam, we have two important column here. Okay, this one, vertical one is P, pressure. P is pressure. And the vertical is temperature. Okay, superheated means the temperature is larger than Ts. So, as example, if the question given, find internal energy for steam at P equal to 5 bar and temperature of 300 Celsius. So, how we can identify the question? We need to compare the T, this one, T, with Ts. How to read the Ts? The first method is you go to page for saturated water, find P equal to 5 bar. Okay, so here P 5 bar. So this is a saturated temperature, TS. So 151.8 Celsius. But the easy method is you also can find the value of TS at superheated steam. Find the 5 bar here. So in this bracket, this is the TS. The TS value is same as pH saturated steam. Okay, so the question need the internal energy for 300 Celsius. So 5 bar, 300 Celsius is here. Then we find the U. Okay, the U internal energy is the second one. So internal energy U equal to 2804 kilojoule over kg. Easy, right? But for the superheated steam, for pH, okay, this one is pH 1 for superheated steam. This is pH 2. And then, okay, at pH 3. Before this, I have explained about the exclusion about the internal energy that at 70 bar and above, the internal energy cannot be read directly from the steam table. As we can see here, here is 80 bar. Before that is 70 bar, have the U. But for 80 bar and above, the steam table doesn't provide the U. So how to find the U internal energy? You can use the formula that I have explained before, which is H equal to U plus PV. Or in specific internal energy, H small h equal to U plus PV. Okay, as example, if the question need to find the U for P equal to 90 bar and T equal to 400 Celsius, so we need to use the formula to find the U. Okay, so 90 bar, T is 400 Celsius. So we need the value of V and H. So just replace H with the value of 3118, and then for V we have 2.991 times 10 negative 2. So H equal to 3118 and V equal to 2.991 times 10 minus 2. Okay, for the P, because the unit is bar, so we need to convert to kilonewton. In formula, we need to have unit for pressure in kilonewton over meter square or bar. Okay, so how to convert 90 bar to kilonewton over meter square or kilopascal. So you can follow the step. It is 90 bar times. So we need to have the proportion. So the bar we need to eliminate. So put it in below the line, and here the unit that we need, we want to convert, which is Newton over meter square. Newton over meter square. Then from Newton over meter square, we convert to kilonewton over meter square. Why we cannot direct convert to kilonewton? It is because in the unit conversion, you can refer to the page for British conversion factor. Okay, where is the British conversion? Okay, this one. Okay, SI British conversion factor. So for convert the unit, you can refer to this page. Okay, as I said before, why we cannot convert to kilonewton over meter square directly? Because for pressure, the conversion is only have in Newton meter or Pascal. 1 Newton meter square equal to 1 Pascal. So 1 bar equal to 10 power of 5 Newton over meter square. So after you find the conversion, so we need to convert the unit for pressure. Okay, here. So the conversion is 1 bar is 10 power of 5 Newton over meter square, and 1 kilonewton is power 10 power of 3 Newton over meter square. Okay, so if we eliminate Newton meter bar, eliminate with this, Newton meter eliminate with this, so we can get the unit kilonewton over meter square. So use your calculator to find the value of pressure. So 90 times 10 power of 5, which means in calculator you just can calculate for 90 EXP, which means exponent 5, and then divide by 1 exponent 3. So the answer is 9,000 kilopascal or kilonewton over meter square. So substitute the 9,000 into P. This one. Okay. P. So the P value is 9,000. So to find the U, just calculate H as usual. Okay. Which means H equal to U plus PV. For H, we have 3,118 equal to U. We need to find U plus P is 9,000. And then the V is 2.991 times 10 negative 2. So, calculate the U. What is the answer for U? So, we get the U answer is 2,848.81 kilojoule over kg. So this is the step to find the U. If the value of U you cannot find in steam table, which are for P over than 70 bar. Okay, so we continue about the steam table. So for the steam table, this is the page 3 for superheated. Okay, then we have a supercritical steam. It is also a superheated steam, page 4. And one more thing, don't forget to write the power of 10 for value of V. Okay, because if you can see here at page 2 for superheated, the V do not have 10 power of negative 2. But for this page, for V, we have 10 power of negative 2 because the value of V is less than the previous page. Small one. The V is smaller than the previous one. So, don't forget to put the 10 times 10 power of negative 2. Okay, so we have for page for superheated steam. And then this is not related for your syllabus. Okay, for this one, you can use as your reference here. Okay, this is a unit conversion for temperature. 0 Celsius equal to 273.15 Kelvin. So, as example, if I have T equal to 20 Celsius, need convert to Kelvin. So, the solution is T equal to 20 plus 273. Okay, in steam table, they have 273 and 0.15. But to get more easier to calculate, we do not have to put 0.15, only use 273 Kelvin. So T in Kelvin, the answer is 293 Kelvin. Okay, vice versa, if you have to convert from Kelvin to Celsius. As example, 400 Kelvin to Celsius. So T equal to 400 minus 273. So 400 minus 273, we have 127 Celsius. So if you forget the conversion value, you can refer here for the value of Kelvin, temperature in Kelvin for 0 Celsius. Okay, other than that, in steam table, you can have the conversion factor that I was explained earlier. This one. Okay, this one. Okay, here you can refer some conversion factor to help you convert the unit. As example for length, volume, time, okay, specific volume, density, energy, power. Okay. Other than that, in steam table, you can also refer here in this box for the value R, Cp and Cv. Also the gamma, Cp over Cv. All the value we will learn in the next subtopics for ideal gas law. If you forget what is the Cp, Cv, R, then you can refer to the notation and unit as I explained before. Okay, so this is the approximate calculation for air. Usually, we use this value when the question do not given a value of R, Cp, Cv and gamma in air. Okay, so that's all for steam table. After this, you can explore on your own to help you understand more about the steam table.